Today I want to look at polynomial division, in particular polynomial long division. And by that we mean something like this, where you have p of x divided by q of x, and you can write it with this notation or this notation. And p of x and q of x are both polynomials. So we've seen polynomial multiplication, but what about division? Okay, and it turns out that polynomial division has a lot of application, and so it's important to look at something like this. And we'll start by looking at real number long division like we did in grade school, because that's going to provide the key in how to do this. All right, so here I have an example, 3 divided by 23, and you think about 3 divided by 23, the way you say that is 3 can go into 23 7 times. Then you say 3 times 7 is 21, right? We said that was 3 times 7. And then I subtract 23 minus 21 to get a remainder of 2, right? We said that was 23 minus 21. And so there we have it. We've divided 23 by 7. Now, the reason I did it that way is because that means I can write 23 in this way. 23 is 3 times 7 plus 2. The way to think about it in general is like this. P equals dq plus r. Okay, and each of these things has a term. So P, or 23 in this case, is our dividend. The d, the thing that we're dividing by, is our divisor. Q, or the number of times the divisor goes into the dividend, is our quotient. And lastly, the r, the thing that's left over, is called my remainder. And this is how division works in general, okay? Now, the one thing we should mention is that your remainder has to be between 0 and your divisor, right? So, for example, if I had a remainder of 4 here, then I did something wrong, because that means I could have taken out more 3's than I did. Okay, so why are we talking about this when we should be talking about polynomials? It's because polynomial long division works the same way. We can write a polynomial p of x as d of x, q of x, plus r of x. And here, these roles are the same. The divisor, the quotient, the remainder, and the dividend. And actually, the long division works just like we did with real number long division. And I'll show you some examples of this, and hopefully it'll make sense. Here, for example 1, I have x cubed plus x squared minus 26x plus 24 divided by x plus 6. Okay, now remember, when we had 23 divided by 3, first we said 3 goes into 23 7 times. Okay, so that's the first thing we're going to do here, is what I'm going to say, the way I think about this, how many times does x plus 6 go into this big thing? The way I think about it is, what times x will give me x cubed? So you think about it for a little bit. I know that if I multiply by x squared, I'll get x cubed. So that's the first thing I write. Okay, then what did we do over here? We said 7 times 3 is 21, remember? Okay, so now what I'm going to do is, just like we said 7 times 3, I'm going to say x squared times all of this stuff. So that gives me x squared times x is x cubed, and then 6x squared. Okay, now what did we do in the real number version? We subtracted, and we got a remainder of 2. Okay, so now here what I need to do is I need to subtract, and to eliminate margin of error, when you subtract, just go ahead and flip all the signs involved. This is going to eliminate an arithmetic error because people forget to distribute that negative all the time. Now when I do this, look what I get. X cubed minus x cubed gives me 0x cubed. X squared minus 6x squared gives me a negative 5x squared. And then I'm going to bring down the negative 26x. And I'm going to play this game again. So I'm thinking x times what gives me negative 5x squared? How about negative 5x? Okay, so now when I distribute the negative 5x, I get negative 5x squared minus a 30x. Don't forget, since I'm subtracting, I'm going to go ahead and flip my signs. So that's going to give me 0x squared. Negative 26x plus 30x is negative 4x. And then let's bring down the plus 24, and we'll play again. Okay, so x times what gives me negative 4x? How about negative 4? Now when I distribute that negative 4x, I get negative 4x minus a 24, and again I'm going to subtract. So that means I flip my signs, and you can see here that there's a lot of room for arithmetic errors, so don't move too fast, just make sure you're doing this thoughtfully. But when I subtract, I get 0x's and 0 is a constant, and there I have it. Okay, so I've completed polynomial long division. Now what does this mean? It means a lot of stuff, and we'll cover more in other videos, but one thing it means here is that x cubed plus x squared minus 26x plus 24 can be written like this. as x plus 6 times x squared minus 5x minus 4 plus 0, right? This is my p of x equals d of x, q of x, plus r of x. Okay, now in particular, notice my remainder here is 0. So what does that tell me? That means I didn't need to really write plus 0, right? So it means that I factored this thing, that this long polynomial is actually x plus 6 times this quadratic. Okay, now we'll come back to that more later on. Right now we're just trying to make sure we understand long division. So let's just look at another example. Okay, so for this time I'm dividing 9x cubed plus 2x divided by 3x minus 5. So I'm going to go ahead and write it in the long division form. And since I don't have an x squared, I'm going to put a 0x squared. This is going to help my arithmetic be cleaner. It'll be aligned better. I have a plus 2x, and again, I have no constant, so I'm just going to put a 0 to help me align my work. Okay, now when I'm dividing, what do I need to do? First I need to think, what times 3x gives me 9x cubed? What times 3x gives me 9x cubed? How about a 3x squared, right? 3x squared times 3x is 9x cubed. Good. So now when I distribute that 3x squared, I get 9x cubed minus 15x squared. And I'm going to subtract, so when I subtract, I want to change my signs, right? Okay, so now we subtract, we get 0x cubed, and we get 15x squared, and I'm going to bring down a 2x, and we're going to do this thing again. Okay, so now I need to think, what times 3x gives me 15x squared? 3x times what is 15x squared? How about a 5x? Alright, so now I multiply everything here by a 5x. I get a 15x squared minus 25x. Okay, now don't forget I'm subtracting. So I changed my signs, and now I have 0x squared and a 27x, and then come down and bring a plus 0, and we'll do this again. Okay, so now 3x times what gives me 27x? How about a plus 9? And now when I distribute the 9 across the 3x minus 5, I end up with 27x minus 45. Okay, so now when I subtract, I get 0 minus 45, and now notice I can't multiply 3x by a polynomial and get minus 45, so that tells me there's my remainder. Okay, now this means a couple of things. So let me show you two different ways you can write this answer. I can write 9x cubed plus 2x as 3x minus 5 times 3x squared plus 5x plus 9 minus 45. That's the first way. The other way I could write it, or the same expression, is divide everything by 3x minus 5. So we were actually asked to find that value. And so that value looks like this. 9x cubed plus 2x over 3x minus 5. And that's going to equal 3x squared plus 5x plus 9 plus a negative 45 divided by 3x minus 5. And so since I started with this expression, that is actually what my answer should look like. How does that relate back to the real numbers? We said that 23 was 3 times 7 plus 2. Another way of saying that is that 27 thirds is the same thing as 7 plus 2 thirds. And since we know about mixed fractions, we know that that's a true statement, okay? So depending on what context, you know which form to use. Polynomial long division is not very difficult. It's boring and it's tedious. So there's a lot of room for arithmetic errors. So make sure you slow down, drink some coffee, pay attention to what you're doing, make sure you distribute your negatives, and just kind of be slow about it. If you do that, it's very easy. Now, the thing about division is it's going to help us, as we saw, factor. If we get a remainder 0, it can help us factor polynomials that otherwise are hard to factor. I hope this makes sense. If you have any questions on this, I'd be glad to help. Please let me know, and thank you for watching.